Hey everyone, it's Mr. Ference. Today I want to talk about a special type of situation in kinematics called free fall. What that means is when an object is falling under the influence of gravity, and the only force acting on it is gravity. Near the surface of the Earth, within a couple hundred feet, all objects, no matter what their mass is, experience the same acceleration due to gravity. This is acceleration, so we can use it in a kinematics problem. We can use kinematics to look at situations where something is falling freely through air. This acceleration is constant, and this is true for everything. Okay, so it's 9.8 meters per second squared is the acceleration due to gravity. This is constant. It's always the same number. And so often we will use this letter little g to represent it. Okay, so make a note of this, write this down, that the acceleration due to gravity is 9.8 meters per second squared. And this is acceleration, right? It uses that same unit of acceleration. So we can use this in kinematics problems. Let's take a look at a quick example of how we would use this in practice. Okay, so we're going to imagine that there's a ball dropped from a tower that's this high, and we're looking at the distance that it falls. How far has it fallen after 1 second? How far has it fallen after 2 seconds? So we're told here that our initial velocity is 0 meters per second. Okay, it's being dropped. So it's basically starting from rest. And we're told, I don't know what my pen is doing. We're told that after 1 second, after 2 seconds, we're figuring out what's the distance that it's fallen after 1 second. What's the distance that it's falling after 2 seconds? Now, the equation we can use is this one, VIT plus 1/2 AT squared. There are two things I want you to keep an eye out for in this problem. The first is that because V initial is 0, this whole first term just disappears. That is because it has been dropped. So keep an eye out for this word. If you see this word, that means that its starting velocity is 0. That will make things a little bit simpler for you. And we can rewrite this as just 1/2. Now, this acceleration, we know it's falling under the acceleration due to gravity. So we know that this is 9.8. So we can actually just write g. So if we're solving for x1, the distance at time 1, this would be 1/2 times 9.8 meters per second squared times 1 second squared. Okay, 1 squared is just 1. 1/2 times 9.8 is 4.9 meters. So after 1 second, it has fallen a distance of 4.9 meters down from where it was dropped. If we do this again with x2, we use the same equation. We're just going to use a different number for the time. Okay, so this is 9.8 meters per second squared is g. And now our time here is 2 seconds instead of 1 second. So 2 squared is 4. This is 1/2 times 9.8 is 4.9. This becomes 19.6 meters. So it works just the same way that we would use any other kinematics equation. But also look here that the distance between seconds is increasing. It's not falling 4.9 meters every second. It's starting to fall a greater and greater distance. That's because it's speeding up. I mean, duh, when objects are falling through air, they get faster as they fall, but the math tells us that too. So in fact, what I want to do is take a closer look at the situation where, imagine I'm throwing a ball up into the air, straight up. So its starting velocity from the second it leaves my hand is 19.6, and this is positive 19.6 because it's going upwards. Now we know that this acceleration is 9.8, but this is actually going to be negative 9.8, because gravity always acts down towards the center of the Earth all the time. And this is actually constant. The entire time that this ball is in the air, its acceleration due to gravity is 9.8 meters per second straight down. So we're calling it negative 9.8. So what's going to happen as we fill in this table is that this velocity is going to decrease by 9.8 meters per second every second. That's what acceleration means. So our starting velocity is 19.6, positive 19.6. After 1 second, it's 19.6 minus 9.8. So it becomes positive 9.8. So it's still traveling upward, but it's slowing down. Okay. After 2 seconds, 9.8 minus 9.8. Now our velocity is 0. Weird. Okay. Let's keep going. We'll see later. We can try and sort out what that means. So after this, now it's 0 minus 9.8. So we get negative 9.8. Since our velocity is now negative, we know that this is traveling now in a downward direction. And then 9.8 minus 9.8, we get negative 19.6. So it's going down, and now it's getting faster. This is very interesting. What this is saying is that if we throw an object up in the air, it moves upwards, but it starts slowing down as it travels upward. It reaches this point right here where for just an instant, its velocity is 0. So that's that sort of turnaround point, basically where something stops moving up and it starts moving down. And then it starts moving downward towards the center of the Earth. And as it continues to move downward towards the center of the Earth, its speed increases. In other words, what this table is telling us is, so this is how physics works. We can take this table, we can do the math, and we can see these results. We can also see the same results with our eyes, with our observation. And we can go back and forth between what's happening in the real world and this math. This is why I love physics, because this is a way to describe the real world using mathematics that gets us the right answer and tells us what's going to happen. This tells us 3 important things about this situation where we have an object that's moving up. The first thing is, at this highest point, at that sort of turnaround point, which we call the apex, at the apex, just for an instant, for a split second, its velocity is actually 0 meters per second. The second thing that this tells us is that the projectile comes back down, assuming that it's coming back down the same height. It comes back down with the same speed that it left. So not the same velocity, right? Because this is this is positive 19.6. This is negative 19.6. But it comes back down with the same number that it left. This is, by the way, why you should not fire guns into the air. The other important thing is that if we ignore air resistance, the path of a projectile has symmetry. That means that the going up part mirrors the coming back down part. So assuming that it's coming back down at the same height, the time it takes to go up is the same as the time it takes to come down. And the speed that it has going up is the same as the speed it has coming back down. Okay, that's it. You now have enough information that you can start working through some of your problems in the problem set. Just remember that acceleration for a free-falling object is 9.8 meters per second, and that is down towards the center of the Earth. Good luck. Let me know if you have any questions, and I will talk to you.